Okay. Okay, so this is what we have last week. Last time we talked about what is the absolute value, and we'll continue with inequalities with absolute value. So these properties of absolute value. Okay. All right. So we'll start from absolute value for these sections. All right. Okay. So where's my stylus? Sorry, I forgot to share. Okay, just repeat because I forgot to share. This is what we have last week about the absolute value. So we start from absolute value today. Okay, so our new sessions. Let me turn off the. All right. Okay, so this is what we call the absolute value. X real number. Absolute value of a real number is this with the vertical bar. The value is the same x if we know x is non-negative. And if x negative, then we stick in negative, extra negative sign. So the properties is that, well, absolute value is always non-negative, and absolute value is 0. That means always means that x is 0, and only if x is 0. The term if and only if, this is the terminology used in math. That means if you have logically, this means something like this. If x is absolute value of x is 0, then x is 0 and vice versa, right? So that's two-way implications. So the second is that if you have a multiplications, a product of x and y, take absolute value, then it's same as the product of the absolute value. The third is you can plus or minus, it doesn't matter. And you have this each of. This is what we call a triangle inequality. Okay. All right, so this is what we have the absolute value. And how we interpret this absolute value? Well, absolute value is actually geometrically, it is distance. Okay, so if you write something like this, absolute value of difference, you can read this distance from X to Y, or from Y to X. Okay. That's the same thing. Okay. Because here, this distance here, distance usually you compute, take something to the right minus send to the left. So Y minus X, right? If X, okay, or X minus Y if this is the case. If you have something like this, X is to the right of Y in this case. So X in this case. All right, so this is distance actually. Okay, so when we write something like what is find X such that X minus 1 equals to 2. Okay, so then that means geometrically something which has distance 1 has distance 2 from 1. 2 from 1. So you take 1, compute distance 2 to the left and to the right. So this is 3. This is negative 1. All right, so this should be X here. Or from here you get X must be negative 1 and 3. Okay, so that's the solution sets. So now you can solve something easily. For example, find all X such that, say, X minus 5 is less equal to, say, 2. Okay, because you can read this as X, everything's within distance 2 from 5. Okay, so now if you can read this one this way, that's easy to solve this one. Okay, so distance from 5. Okay, so take distance 2 to the right, that's a 7. Distance 2 to the left, this is 3. All right, so this is within and 2 included, so that's the solutions. Is 3 to 7. Okay, so provide if you can read these equations in a more verbal way that a human language you can understand, then you can solve this easily. Okay, so the thing is, let's see, is there any more mathematical way to solve these equations? So this is by, I say, by geometry, distance. That's easy. What if you solve this algebraically? It's a bit complicated, but let's do this one just to give you an example uh, how to make sense of this, how to make this problem. Okay, so that means we have to take the meaning of x minus 5 absolute value. All right. Okay, so that would be x minus 5 remain x minus 5 if x minus 5 is non-negative. Okay, x minus 5 is non-negative. That means x is bigger than 5. You solve this one. Okay, and becomes the negative if x minus 5 is negative. So that means x is less than 5. Okay, so you have two cases bordering at 5 here. So for x bigger than 5 means to the right of 5, this is x minus 5. Okay, and to the left of 5, that means minus x minus 5. Well, better write this way. Okay, so basically you have two inequalities now. To the right of 5, this inequality becomes x minus 5 no more than 2. And the second inequality is more minus x is. So you're solving two inequalities at the same time, simultaneously. Okay, so from 1, you get, let me rewrite this one. So you solve this, you add 5. So this 7. Okay. Or you have this case, the second case, and you solve this one. So minus x is you subtract 5 and multiply by minus 1. Okay, so that's bigger than 3. Okay, so you see the solution would be sorry, this one. X is less than 7, 3. Sorry. What's wrong with this one? I think this is not, or this is n, sorry. Okay, so you have the solution set from 1. From 1 you get this, 7 is included. And solution set from 2 is 3 is, 3 is included actually. There. And because of the n, so the solution set is this, you you intersect with this one, 3, 7. All right. So that means you get 3 to 7. The same as this one. Okay. So you can compare this one. If you're doing this geometrically, so you read this inequality as a distance, you almost instantly get the solutions. Or if you do this algebraically, so you break up into cases and solve each one, and you intersect the solution sets from each of the cases. Okay. Any questions? All right. All right. So let's do some more example for this one. Let's see, any problem from the tutorial sessions? Let me check. Oh, cannot get to the, oh, okay, tutorial sessions. Okay, so another example. So solve, meaning you find all the solution sets, all the solutions. Okay. All right, so what it means here. So let's solve this geometrically. This means the distance you read as distance from 2x to 1 is bigger than 1, is more than 1. All right, so if you solve geometrically, just like this one, distance 1, 1 to the right, so it's 2, 1 to the left, that's 0. Okay. So what's the solutions? Everything's has distance more than 1, so that means this one or this one. But remember, what we draw here is not the x-axis, but 2x-axis. Okay, so that means 2x is more than, it's bigger. Okay, so bigger than 2, or 2x is less than. Okay, so that means x bigger than 4, or x less than 0. Okay, so the solution set is, let's see, bigger than 4. This one is, and union with x4. There we go. Okay, so this is how to solve this one. Questions?
Nope.
All right, good. Third one. All right, so this is the Let's see. Give you example. Something that you might have done differently when you're in high school. Solve this one. Okay. So again, how you solve this when you're in high school?
Move the x minus 5 to the left and then add and subtract it.
Add subtract what?
X minus 1 plus x minus 5 and then x minus 1 minus x minus 5.
That doesn't help.
Well,
anyone? What you do with this one? Oh, let me give you some more example first. I'll postpone this one. We'll do this after. This one is something easy. Solve this, for example. How you solve this one?
Five is less than x minus 1 is less than minus 5. Oh, that will be, oh wait, I'm trying to solve it.
All right. Any other comments? Others? How you do this one?
6 is smaller than x is smaller than minus 4.
How you do that one? How you see this one? Or I should A and B actually solve this one, and let's see. Oh, okay. Okay, how you see the difference between these two inequalities? Have you ever encountered this kind of problem in your high school with absolute value?
Yes, most of the time.
So what you do with this one, with this type of inequalities?
Usually I just squared it.
Yes, the thing is, all right. That's the thing. You square those. All right. Some squaring works okay. Some uh, some doesn't work, and some just awfully wrong. And so this is the example when squaring won't give you answer or give you wrong answer. So note here. Or just solve this way. I'll show you squaring if you incorrect answer. All right. First, how you read this one using distance functions. Distance from what to what is less than what? How you read this one? Distance from what's what? As above, how you read this one? Distance from what?
Distance from x to 1.
Yes. X to 1 is what?
Less than -5. -5.
Is less than 5. But distance is never negative, right?
Yes.
Right. So is there anything that has distance negative 5? Negative. So this distance is non-negative. So if one asks for distance negative, what's the answer should be? Any x satisfy this has negative distance? Nope. Right? So what's the conclusion for this one?
There are no solutions.
No solutions. All right, so solution set is empty set. Or you can write this one. Okay. So just by interpretation of distance, you can solve this without even computing. Okay. So that's one of the beauty of the reading this as a distance function, because you have some picture in your on your mind what's the distance must be. All right. What about the second one? What kind of x satisfy has distance to ones bigger than -5?
X more than 1.
X more than 1? All right. What about 0, for example? X equals 0.
Yeah, I think that works too.
So what kind of x satisfy the inequality?
All real numbers.
All real
All
numbers.
numbers.
All real numbers, because there isn't any restriction to this one, right? Because the left-hand side reads distance, right? But the right-hand side is negative number, and distance is always non-negative, right? So for any x, this one is bigger than 0. So for sure, that would be bigger than -5. Okay, so the solution set is this one. All real numbers. Okay, so these two are the, say, the extreme situations when you get solution sets is empty, or this is all real numbers. Okay, but you can see this easily just looking at the absolute value as distance. Okay, all right, let's do something that you are told when you're high school, squaring this one, right? Okay, so let's do it by squaring. All right. If you square this, you get And you want to solve something like this. Okay, so this give you x. Oh, 1. Let me find something that might be easier. The number would be easier. Just 1, 1, 0. All right, so this is just okay, square. Okay, so you get, so you have 0. All right, so you factor this. Okay, and use a sign chart. You indicate two numbers, 0 and 2, right? And if you check the sign, that would be plus, minus, plus. This for x. Okay, so the solution set for this is the one that's negative. So right. So let's see. You think you have solutions, right? So let's plug in 1. So try 1. So you substitute 1. 1 minus 1. That's 0. So 0 less than negative 1. So that's incorrect answer. Okay. All right. So this whole thing is incorrect, actually. So where's the uh, wrong step here in the work? So the wrong step is from the step 1, actually. That squaring thing. Okay. The thing is, by squaring, you lose one information. One important information, that is sign. Because negative becomes positive if you square. And that be important if you work with the absolute value. Okay, so that's why you don't get a squaring is wrong in this case. Okay, so what about this one? Okay. Well, in this case, if you try to square it, you get x squared minus 2x minus plus 1, right? So like this. And you sort of subtract 1. So you, right? And by sign chart, you indicate 0 and 2. Check sign, plus, minus, plus. Okay, so you find the negative one. That is the solution set. Okay, so this is the solution set. Okay, so you see here, if you do the squaring, then there won't be any difference between absolute value x minus 1 less than 1 and this inequality here. Okay. So this is the say a case when squaring is okay. Okay. What was wrong in this case is you're squaring. So what went wrong? This one, squaring negative. There. Okay. So squaring negative number, that's give you you lose informations. Then you won't get the solutions. Okay. Questions? Okay, sample 3. Let's do this one. All right, so we deal with the two absolute values. Now with absolute values, so try to read this one as distance. And you see you can solve this easily. Okay. So what's the left-hand side? How you read the left-hand side?
The distance from x to 2?
From x to 2 is less than distance from x to 4. Okay.
Ah, all right. But
Okay.
I'm unmuted. Whoops.
So is distance in terms of less than or more than is how you call it in verbal in words. X is nearer to 2 than to 4. Okay. That's how you read it. All right, so let's 2, 4. Okay, so let's determine whether x is nearer to 2 than to 4. Okay, so we have 3 cases, right? What about here? If we choose x here, for sure this is nearer to 2 than to 4, right? This is closer to 2 than 4. Okay. So for here, it's all right. This is closer to 2. All right. What about between 2 and 4, or to the right of 4? Here, for example, is this correct? X here to the right of 4 is closer to 2 than to 4.
No.
Nope. So we won't have solutions here to the right of 4. Okay. What about between 2 and 4? Or find something that has same distance to 2 and 4.
Then it must be 3.
Yeah, that's 3, right? So to the left of 3 is closer to 2. To the right of 3 is closer to 4 than to 2. Right? So this won't be solutions. So we have now the solutions. What's the solutions? This one, solutions. Okay. So that is the easy way how to solve this one geometrically. right? So minimum computations. So three cases, right? To the, this is closer to 2. Okay, so for x bigger than 4, this is closer to 4. Okay, so for x in between, all right, so you and then 3 closer. Yeah, 3 cases. So the solution set is, let's see, there. Okay, no squaring needed. Although you can do squaring for this one. Why you can use squaring? Because both sides are non-negative. So if you square, it's still non-negative. So you won't lose sign informations. Okay. A contrast to the second example here. This one. If you square those, that the absolute value less than -5, then you lose information of that -5 because it becomes positive. All right, so the moral of the story is that losing informations in doing operations is not good. Okay, so something that you should avoid. I'll show you how to do this algebraically. Right? Because for more complicated cases, that's the only way that we can do actually. All right, so let's do algebra. Four, right? Okay. So let's see. Here, 2. This is 4. Okay. So to the right of 4. Let's see how to. Okay. This is x minus 4 and 4 minus x to the left of 4. Okay. This is minus 2 to the right of 2 and 2 minus x for 2 less than. Okay. All right, so now we have 3 cases. So to the right of 4, the absolute value x minus 2 is actually, right? So here we have x minus 4. And in the middle, between 2 and 4, you have, let's see, this is minus 2, right? But the absolute value x minus 4 is actually this one because that's to the left of 4. Okay, and to the left of 2, you have 2 to the minus x. Okay, and less than. So we have 3 cases. All right, 2 or 1 or 2 or 3. So for 1, so case 1 is for x less than 2. Okay, so we solve this one. Okay, so add, how to solve this one? Let's see, what is this? Is that correct? Oh, yes, correct. Okay, how to solve this one? You kind of, right? So here you end up with, so that's correct for all x. Okay, so the solution set is, but why is should be restricted to 2 because of this one. All right. Second case. Case 2 is for x between 2 and 4. So the inequality is, okay, so we add x both sides, add 2 both sides, okay. So the solutions that you get is by here. So you intersect those two. Okay, so what you get? So what we get here is x less than 3, and so x between 2 and 4. Sorry, 2 and 3. There we go. Okay, and what about the 3? X greater than 4. Okay, you solve this one. Okay, so you cancel x, but you end up with -2 is, so that means no solutions. Oh, sorry, missed this one. Okay, if we divide into these 3 cases, there are 2 points left. There are 2 points left out here, 2 and 4. So somehow we have to include 2 and 4. For example, if this and include 2 here. Okay, and this is there. Okay, so we have this instead. Oh. What about this one? Sorry. Shoot. What is this thing? So eraser. Sorry, I should do. That is from other file. Why this? Sorry. Let me just rewrite this one. It shouldn't be there. case 3. Okay. So x bigger than 4. So you're solving x minus 2, x minus 4. False. So no solutions. All right, so from case 1 and 2, 3, that is okay. So if you add them up together, so you have there. That's the same as this one here. Okay. But there's clearly give you the idea what's the important thing is being able to read this as distance functions, right? Because in terms of distance functions, you can work it out easily, easier than this using algebra. Okay, questions? All right, let's take a break for 5 minutes.